So this presentation is about Tekla Construction Management solutions, and I'm planning to show you about the key features, of course the benefits, and some real life examples. So I think we should have like a game. So we have this project, and we should start soon. It looks like a normal basic office building, 7 floors, 35,000 square meters. The drawings are not yet there, and we should start the construction in few weeks. What can we do? It's a real project. We can see it's called Ilmarinne in Helsinki. You can see all the project parties on the right bottom, and we have a challenge. Of course, we want to know quickly what kind of project we have. Try to identify all the risks. We've been talking about whole day about reducing the risks. We want to minimize errors in design and get the reliable information. We don't have the drawings, but we can still use the models. And of course, we want to assure the schedule. The frame needs to be on time. So in this presentation, I try to show how maybe BIM and models can help you with these things. So first, in the design phase, we want to, of course, minimize the error. Well, we heard already how BIM helps, but let's see my point of view about that. Of course, it's easy to understand, and also we need the detailed constructible models so we can see that everything fits together. And of course, clash checks or clash avoiding, which I'm going to show you soon. This is one example, real-life example, not a good one, so that's why I didn't write the project name and the project parties here. So every year we got a lot of different models in this Tekla BIM Awards, and this was a couple of years ago, and sometimes I want a little bit get to know and check the models. And this is the roof structures of one building, and we can see that the ducts and the wooden structures are clashing heavily. And if we look at a little bit more, we can even notice that there is no easy solution for this. No minor changes, it should be some major change or something. And this was already designed project, so we know that every project is not perfect. But this other example, this year's competition, Trimble Finland and SRV Construction, one of the largest general contractors in Finland, they had this Opimen campus project. Also a complex project where they commented that without modeling, it could be nearly flawless design with the modeling. So with the model, it was nearly flawless. And the project was design team did the class checks, and also the contractor put the models together. And everything was did by IFC-based system. So here's some example picture about this project. So everything's detailed, of course, everything fits together. You can see the connection joints. And this is always the hardest part of the building, the HVAC machine room, top of the building. And if you look, it's quite small picture, but we can still see that there are no clashes. All the ducts are going nicely, but no clashes there. But if you look at today's demo model, I have this Ilmarinne model here. It's a quite big project, fully detailed, everything was modeled. Let's check a little bit through how it looks like. So like I said, everything is detailed, so we can see that everything will fit nicely. All the cast in place, all the precast, all the steel. So it's a multi-material project. 3 office buildings, like I said, in the first phase. Maybe second phase, 2 office buildings more right there. 2-story basement. And like I said, also HVAC and MEP was modeled. And if we go look a little bit inside the project, we will see that, okay, it looks normal, everything's there. But what they used, the map designer, structural designer used this whole reservation, IFC-based whole reservation system in this project. This is what I meant about class avoiding. So it works that way that the map designer creates a whole reservation in his or her own software that he's using, and then send the IFC as a whole reservation to Tekla structures. Then the structural engineering can accept or say that it's not, you cannot create a hole in this structure. Now we can see that this red one is the hole, and then we can see that the ducts go through the hole. We can even click it and see that it's a void. That's the name of the object that when it's a hole. So using this, they can communicate and they can make sure that all the holes are in the correct level and correct location. So of course class checking is needed, but this is like class avoiding. So if you use this system, you probably will not have that much classes in the class checks. Okay, let's go further. So okay, first thing we need to build a building is a foundation. No surprise. So, but the problem is that we don't have the drawings. And I heard this in many projects that they still can start doing and planning the project. They have the model. They need to have some quantities, coordinate system, reports, materials, and that the model can provide. So let's see an example. Let's continue with the Ilmarin project. Let's hide the reference models and the rebars, and let's go deeper to the foundation. Like I said, it looks like quite basic office building, nothing special, but this is the way, easy to understand. Now we start going through the foundation and notice that, okay, there's quite much actually different levels, elevations. And of course, that means that there could be a lot of challenges on site also. So first the quantities. Now I open the first tool that we now in Tekla Structures 20 have in all configurations. So if you have Tekla, if you have using Tekla 20, you have also the organizer tool, which is the quantity takeoff and information management tool. It's quite small there, but probably the idea will be the most important thing. So on the left side, we have the reporting, all the objects, all the quantities, and the right side, we have the locations and the groups that we can customize and create. So for example, if we want to quickly get the quantities, we can just select from the model. Let's select all the footings like that. Then on the left side, we can easily, for example, use the grouping tool and see. Let's quickly there. Okay, we have probably 4 different kind of we have 4 different kind of footings, and then we go and see, okay, we're interested about the cubic meters, so 1,700 cubic meters there. So that was the easy way. Of course, we can start planning. So should we pour or plan this area first, see how much there is formwork or how many cubic meters concrete. So we can quickly take different kind of quantity takeoffs from the model. Okay, we're also interested maybe about reinforcement. So I can quickly create this group using everything here is organized as rule-based. So it's based on, for example, filters. So if we say that these, based on the name, these should belong to foundation. If there is a new object and it calls foundation, it will automatically call that group. So it's rule-based, and that means that it's easy during the design or when you have a new model to check and let's see. and manage the information. So I created a new group that it will check all the concrete parts and then the rebars. And let's check what kind of result we have here. So you can imagine how long it takes to calculate all the rebars from this size of project, from the footings. Let's just wait a second. Then I create a grouping based on size and the bending type. And then, for example, let's export it to the Excel. So here we have now on Excel sheet all the rebars that we have on footing. And we also have the grouping that we had in the organizer tool. It's still here, so we can easily see that, for example, size 16, we have 36,000 kilograms. So quite much about those rebars. So quick and easy reporting to Excel. And of course, I was talking about the coordinates, and PSD also was interested about this surveying point, measurement points. And like I said, in this project, there's a lot of different levels and elevations, so that might help the construction site guys to install all the formworks and rebars on the right location. So here you can also already see that I've created some surveying points. Those can be easily added manually or using components that will recognize, for example, all the top or bottom corner points and add automatically these surveying points. So we can easily see that, okay, here is might be some challenges, so let's add some points. And then again, using this organizer tool or some other tool that we have, you can easily see the report now here, all the coordinates and the name of the points. And these reports are customized, so you can customize these. So if you have, it depends what kind of device you're using on site, you can customize the report and get the information to machines. Okay, let's continue with the presentation and some real case again. So this is a Destia case, Destia and Silta bridge project where, well, Destia is one of the largest civil construction companies in Finland. It's not a big bridge, but you can see it's fully modeled again. You can see also some plumbing there. All the cast-in-place structures fully detailed. But maybe the interesting thing we can see here is that they also modeled on site some temporary structures, supports or formworks, and also we can see that there's a lot of surveying measurement points also. I know in this case that the designer has also added some of these points, but on site Destia can also use they use Tekla and they can add the points ad hoc what they need and get the information. We can see that, well, there's some details, but we can also see that there's a lot of measurements inside the bridge. So during the construction work, they need some points and some coordinate information. So all the red dots here, there are the surveying points. Yep. Okay, next we managed to build the foundation, and then let's back to the frame. That's of course the most important. If frame is late, the whole building is late. So the important thing is that Katja showed you how Vic Office you can then now create the general schedule based on the model and the real quantities, and then we can continue from here with the daily level installation plan. So the schedule is based on Vico Office schedule. So let's go back to the model again, and let's turn the whole building so you can see it. And then open the next feature that we have for the project management is the task manager. That's the scheduling tool that we have in Tekla. And it looks like this. It's a basic Gantt chart schedule that you can see in the task list on the left side here and the calendar side here. And actually this schedule was imported from Vico. So it looks like a flow line in Vico, but when you import it to Tekla, it will convert it to Gantt chart mode. So you can get the task names, the start date, end date, the duration. So you get all the needed information from the Vico schedule planner to Tekla task manager. And then we can continue going more detail level. So let's, for example, check that we have this A building. It's here. We can highlight the building A here. Let's wait a second here. There it is. And we can see that, okay, let's concentrate now on the first floor. So it will highlight the first floor. And we can see that it includes 205 precast elements that we should install. And let's go deeper to this first floor. We can hide all the other structures, so it's more easier to check what's the situation here. So we can see, visualize that this is the section A and all the precast. Now the floor 1 in building A. Then we can go inside that task and check that here we can see all the precast elements that belong to this task. And what we can do next is start defining the installation order or sequence from the model. I already done it for the first floor, and I can visualize it from here. So it starts with the columns. It's a column beam hollow core building or structure. So let me just a little bit like this. And now we can see that. Let's start with the columns. What's the order? First columns. So I manually added this installation order. It could be based on some code or number or what else. Then comes the beams. And last we got the hollow core slabs. And so we get the duration from we got the general schedule and the installation order now from here. Then we can calculate that what's the exact date. For example, this column here, it should be installed 5th of December. So we get the exact date. The daily level schedule is now here. And that information we can report or also use many things, or the visualization, for example. Okay, let's get back to the whole building so we can check from the second floor how it looked like. Because the idea was that I didn't add any installation sequence to the second floor, so we can visualize and see how it looks like. Is it possible to erect in just a random order? Just to visualize that this is a really easy way that to notice that which is the correct order. Is it possible to erect in this order I planned? Let's see. So let's see all the objects. Okay, so now it's totally random order, and we can easily see that, okay, immediately we notice that it cannot be installed in this way. There's a column and there's a beam, and there's no support for that. So it's a very visual tool. You can immediately see that is this the right order for the installation. So again, you can quickly see on the model, is it possible? Okay, let's go next thing. So we can now start doing the visualization. So that's of course the important thing. So now we have the dates on the objects, and then we can start doing some basic visualization. So now I have rule-based tool for changing the color for the model. So now we can see that there's no objects in the model, but when we start first jumping, we can see that 5th of December, we should install all these precast elements you can see on blue. And I know there's a weekend between there, so let's jump a couple of days forward and then see that, okay, now the hollow core slabs are there. And next day. Okay, now we will see that the second floor comes, and I didn't add the correct installation order, so we can, for example, see that this column, it's not possible to install here. So you can easily see, same here, hollow core, no support for that. Also here, problem. So it's a visual tool for understanding what's happening next week, today, or whatever. So we can use this as a jumping 1 day or week or 2 weeks. So it's a like visualization tool for that. Okay, so let's see again a real life example. This is a Skanska case where Skanska, well, you can read what the procurement manager and site manager says about Tekla models on site. I did the Pentti Holm comments, excellent tool for visualization, work packages, and schedule. That's what I think what they use in many projects. And this is Manskurasti project, Rambo Finland and Skanska. So it's a couple years back, Skanska's new headquarters. So you can see the week number changing on the right bottom of the screen. That's the week number. And different color means always a different thing. Is the green, it's formwork, red might be reinforcing, and then the actual casting. So this is the visualization for the basement. It's actually quite same kind of building that Ilmar in a project that I'll be showing you also. And the next video, then we can jump to that, is the precast frame visualization. They also use this, like we're talking about today, communication. This is a great way to communicate that this week happens. These are where the installation is ongoing. It's also a safety thing. If you know that the installation is going in that corner, don't go there if you are not responsible for the installation. Next thing, now we've been doing the scheduling for the object level and the daily based schedule. The next thing is, of course, the controlling it and following the progress. And let's get back to the model. And let's, for example, say that just select from the model that, okay, these elements we already installed, and we installed actually the date that we planned, so we're on schedule. Yeah, and then we just change the color setting to show the progress tracking, and then we'll get another visualization of that. Again, a very visual way of showing things. So the blue things, those are already installed. And we can see each object that it was planned 5th and it was installed 5th. What about the red ones? Let's select it was planned 5th, but there is no information about that it was installed. So we know that it's late probably. So we can quickly see that, okay, the red ones we should be already installed, but not. So it's again visual way.
Sampo, one question.
Yeah.
Is it possible, let's say on site, how to enter data about actual erected, not erected elements.
Yeah.
Only just manual way, or?
Yeah, there's different way. Good question. So one way is that you can manually add to each object the date. Another way is through also from the task manager. Here you can also add the dates. Here's the start date and end date. But one good way also is that Excel template can be used. Sorry. So if you create this Excel template, you can read the data straight from the Excel template to the model. And it's a quick and easy way. So normally if your subcontractor can fill the template, you just read in the data and get the color settings and information correct. There's a question.
Somehow connect this software with the warehouse software, so that material or part which is going out from warehouse.
Yeah, connect to. Yeah.
Is it possible to somehow connect this software with the warehouse software, like database, and for example, that construction or part which is going on from warehouse is directly here?
Well, we have many integrations with different ERP or systems, so probably yes. Of course, it depends about the interfaces that the other system has. We are quite open software and integration with many. For example, in Finland, one precast fabricator, each night they can send the fabrication information straight to Tekla. So there is a lot of different kind of integration. So yes, it's possible. And that was also a good question for the next thing. So this is not only for the installation. This could be for the design, detailing, or fabrication. You can follow all the things in the model. This is an example of the KPMG office in Helsinki where Lemminkäinen followed the design phase. How the design of this casting place frame went, so they on site followed with different colors again. So if the information is in model, you can visualize it easily.
Could you show again in the status table, Tekla?
Yeah.
What standard status we have? Yeah, because back I'm sure that they can read that. Just please comment what we have here.
Okay, yeah. So for example, we have each object has this workflow page where you can see the design, fabrication, and erection phase information. And we have for design, we have own date fields, also status, is it incomplete or completed. For fabrication, we have much more. It could be on warehouse, it could be in assembly, or it could be shipped to the yard. So there's a lot of, and this can be also customized. So today I will only showing this erection phase, but you can also follow and plan the design and fabrication phase with the same tools. Okay, then the last phase in the project, of course, is the internal phase. We know that there's a lot of internal works, map, HVAC installations, internal walls, and all the things. So first thing, of course, class check should be done, but there's still information needed, measurements and visual checking. That's what PST also mentioned, that how they used. Here's again Skanska example, what kind of BIM tools they use on site. Solibri model checker also mentioned they use it on design coordination. They use Tekla Construction Management solution for scheduling and the progress. Tekla BIM site on the viewer are viewing the model. And then the latest one is the mobile app. So Tekla Field 3D is the mobile app you can use in iPhone or iPad. And that you can easily visualize the model when you are on site there walking. And these kind of things, of course, you in daily work when you're on site, you need to see all the connections, all the details. You need to get some measurements for the pipes or ducts. So this kind of information you always need. And Skanska uses this field BIM, so they have different solutions for this, also iPads, mobile phones. They call this BIM kiosk. It's a computer on site that everyone can use. But maybe the most important thing is the how they use the mobile phones or mobile applications on site. So let's take a video, how it works and how they use it. Now let's see. Okay, so that was the Tekla Field 3. That's quite new and probably you all has heard about. So if I had time, I could quickly show a little bit about that. So yeah, let's try it. It's a video. So it's actually it's based on also IFC, so it opens all kind of IFC files. It's really quick, even quicker than some other softwares we can provide, but this is really quick, and big models, fully detailed models you can visualize and view. We have the same tools that Tekla BIMsite, for example, clipping, cut planes, measurements, walk inside, and the measuring is also easy and handy there. And that's what I think they are using quite much on site, like they said in the video. And we saw also in the video, so it's not about the age, or it doesn't matter if you don't have the same language you can talk. If you can see the model, you can understand both what's happening. And if you want to see it in real life, I have iPad here, and during the coffee break you can come and try it. It's so easy that probably everyone can use it straight away. But at the end of the presentation, I just want to mention a couple of things. So the solutions these was the challenges, how to get to know your project and identify the possible risk. Of course, the model is, and the information is the solution for that. And how to minimize errors in designs. It should be a detailed model. We see when it's detailed, everything fits together. Class avoiding, class checking, of course, that's the most important thing. And how to get the reliable information, even if you don't have drawings. You can use the model, you can use the location-based quantities. And of course, if you want to make sure that your building is on time, you can use the general schedule, integrate with, for example, Vico Office, then control it by daily level in Tekla. So that's the solution for that. Thank you. Any questions?